Welcome you all again. In this video, we are going to have a small introduction about logarithmic. Before starting the chapter, before having introduction about logarithmic, let's have some previous KT. What do you want to know about KT? KT just a corporate word. It means knowledge transfer. That means before starting the new thing, we will have some previous knowledge. We will transfer ourselves, like that knowledge should be transferred. So we can connect one new chapter with the previous one. So it will make this thing easy. So let's have some kids. Let's have one example. 2x plus 3 equal to 11. We already saw these things. I think so in class 6 or 7 and 8 or 9 and 10. Again, we are going to have this as an example. We need to find the value of x. For that, we will set this 3 in the right hand side. It is an addition. When we set this 6, this 3, in right hand side, it will be subtraction. Why? Because we know this thing that if we want to set this 3 here, we are going to subtract minus 3 both sides. So it will be 3 minus 3 0, and here it will be 11 minus 3. So it is what? 8. That's good. Here it is 2x. So 2x means what? 2 is multiplied by x. We want only x on our left hand side. So we will set our 2 also. 2 is in the multiplication. And when we set it, it will be 8 by 2. That means what? It means 2 is in division. When it is shifted to right hand side, it will be 4. So can you tell me one thing, that what is 4? 4 is the result, 4 is the value of x, but what is 4? What is the value of x? That means 4 is that value that will be multiplied to this 2 to give this result. Got it? It means when we this multiplication down, when we shift it, we get one value that will be multiplied to that previous number to get the result. We are going to have this one thing that if we shift plus to the right hand side, it will be negative, negative, positive. That is subtraction, addition. Multiplication will be shifted to what? Yes, division. Division shifted to multiplication. And one more thing. If we are having x to the power 3 equal to 8, then if we want to set this power, we want to have the value of x. So we will set this power. So this power will be in reciprocated form. That it will be 8 to the power 1 by 3. And when we solve it, we will have like this, and our value will be 2. And what this means? It means, what it means? It means 2 is that number that will have power 3 to give 8. Okay? So it is just a transformation thing. Hope you all get it. So all of these give us the thing to have scope to represent numbers or to play with numbers. The logarithmic is approximately or completely the same thing. It is also a form of representation. Okay, so I hope so this will be enough to connect with this thing. So we are going to start the chapter now. What is our chapter? The chapter is logarithmic. What is it? Logarithmic. Any real number can be represented into two forms. Any real number. Real number means what? Any number that whose power will be greater or equal to than 0. And that can be represented on what? Number line. So any real number can be represented into two forms. Exponential representation or logarithmic representation. Exponential representation is already, we are familiar with this. We can say this thing, these are the logarithmic representation. We are going to have logarithmic representation. I want to tell you one thing here. These are the inverse of each other. These are the inverse of each other. What is inverse? similarly, say plus is inverse of minus, minus is inverse of plus, multiplication is inverse of division, and it's right, division is right of inverse of multiplication. So exponential, then exponential is the inverse of what? A logarithmic, and logarithmic is the inverse of exponential. Okay. So let's have the introduction. What is log and how we derive it? So it is written here derivation of log. Derivation of log is what? We are known to this thing y equal to ax. Y equal to x. I have just written here x to the power 3 equal to a. That means this is our y. In this case, this is a and this is x. For the same thing. So from this equation, we are going to derive our log y equal to a to the power x. But there are some conditions. Our y should belong to positive real number. Our y should be positive real number. X belongs to real number. X belongs to real number. A should be greater than 0 and a should not equal to 1. With the upcoming examples, we will be clear that why these conditions are being followed. And these conditions are going to be followed in each and every question to give you the perfect answer. Otherwise, you will be have some confusion. So just remind it in your mind. A should be greater than 0. A should be greater than 0. A should not be equal to 1. X belongs to real number and y belongs to positive real number. Okay? So let's come to this thing. Y equal to ax. That there we get the thing that if you want to set this x, we will write a equal to y to the power 1 by x. A equal to y to the power 1 by x. But right now we are so much bored with this thing. Therefore, right now we want to have some adventure. We want to have some new adventure. So here we want to set what? We want to set the base. I want to write here x. If y equal to a to the power x, what will be equal to x? What will be equal to x? So this base will be here. It will give us log like this. Okay. So when you set like this, if you want to set x to the power 3 equal to a, so x equal to a to the power 1 by 3. When it comes to right hand side, we get this upon sign 1 by 3 or 1 upon 3. So we are going to get some extra things. So here we want to set the base. It's a big thing. If you want to set the base, it's a big thing. So we are going to update that thing. We are going to 3-letter word log. This is short form of logarithmic. Okay? Log a y equal to x. Here we get the derivation that how and from where we get the log. To remind you, to make it easy to remind you, let me clear one thing. Here a is what? Base. Here a is what? Base. And x is our power. So when it comes to the other side, it's still the base. It's still the base. Log y base a equal to x. And we are going to read it like this only. Log y with base a equal to x. Okay? And what it said, you can see x was the power, a was the base. So a to the power x equal to y. Okay? Let's have some example to make it more clear. If we want to solve log 81 with base 3, that means what? What is being asked here? It is being asked here, what will be that natural number, or what will be that number that will give 81 when we use that as a power of 3. Okay? Let me solve it. We want to fill this block, so it will give us 81. It is being asked here. So 3 is our base, no doubt. We want to find that power. So we will get 81. Okay? What? Would you say 3 to the power 4 equal to 81? That's correct. power 81. And if we let it as a x, so 3 to the power x equal to 3 to the power 4. We are already known to this thing. If base are equal, power should be equal. So it will be x equal to 4. Okay. So what is our answer? X. That is said. And we get x equal to 4. So we can write our answer as 4. Get it? If you want to note it down, you can note it down like this. Let 3 to the power x equal to 81. It will give us 3 to the power x equal to 3 to the power 4 and x equal to 4. Get it? In a similar manner, we are going to solve all of them. What will be the power of 3 to get 81? So that is 4. 3 to the power 4 equal to 81. Now, next question. What should be the power of root 2? What should be the power of root 2? So we get 32. What is 2 to the power 5 equal to 32? Yes. 2 to the power 5 equal to 32. But wait, the question is root 2. What will be the power of root 2? Okay. You are saying root 2 to the power 2 will give 2. So root 2 to the power 5 is 10 equal to 32. So log 32 with base root 2, answer will be 10. That's good. Here 1 by 5 and 5. What will be the power of 1 by 5? So it will give us 5. Then you will say 1 by 5 to the power minus 1 equal to 5. Okay? 1 by 5 to the power minus 1 will give us 5. So here our answer is minus 1. Now we will have some big thing. 97 to the power something equal to 1. 97 itself is a big number. What will be its power? What will be its power to give us 1? The very small number. One of the smallest natural number. To get the smallest natural number, what? You are saying standard 8 or 7 you get the thing with power 0. Any number can be shifted to 1. Yes, that's right. 97 to the power 0 will give us 1. So here we will have answer as 0. So 97 to the power 0 will give us 1. Now let's play with some trigonometric things. Here. Trigonometry. Log 3 log the tan 30 base 3. That's what will be the power of 3? That will give us tan 30. So recall the standard 9 where in chapter 8 you got the table of trigonometry that here there tan 30 is value of tan 30 is given, and that is 1 by root 3. 1 by root 3. So 3 to the power what? 3 to the power what? Give 1 by root 3. So can you say 3 to the power 1 by 2 will give root 3, and since we want it in the denominator, we will put minus 3 to the power minus 1 by 2 equal to 1 by root 3. So here we are going to have answer as minus 1 by 2. Now, let's solve it here. Log 2 plus root 3 base 2 minus root 3. Initially, you will see as a big one, but let's have some breaking process. 2 by root 3. Do you know about rationalization? Can you do it? Of course you can do it. When you will do it, you will get 2 to the 4 minus 3, that is 1 by 2 minus root 3. That 2 plus root 3 is equal to 1 by 2 minus root 3. So this particular thing can be replaced by 1 by root 2 2 minus root 3. So it will be log 2 minus, sorry, 1 by 2 minus root 3 with base 2 minus root 3. Yes, to get it right. It is similar as this 1 by 5 to the power something equal to 5. Here something to the power equal to 1 by that thing. So here again we are going to have minus 1. 2 to the power 2 minus root 3 to the power minus 1 will give 1 by 2 minus root 3. Okay? Get it? Yes. Now let's have the next thing. Log sine 45 degree base tan 45. That sine 45 is what? Yes, we call it sine 45. Sine 45, sine 0, 0, sine 31 by 2. Sine 45 is equal to? Yes, 1 by root 2. So log 1 by root 2 base 1. 1 is what? Tan 45. Tan 45 is what? 1. No doubt? Well. Now the question is 1 to the power something equal to 1 by root 2. Yes, just give me an answer. Give me an answer fast. 1 to the power something equal to 1 by root 2. What? What you are saying? How much you want to limit? It is violating our condition. What was the condition? A cannot be equal to 1. A cannot be 1. Here log something with base A. Can you recall the things? Log something with base A. A cannot be equal to 1. So A is here 1. So this is nothing. This is just a question. We are going to write undefined. Undefined. That means this thing cannot be explained. Undefined. Everything has some meaning, but everywhere there will be some exception that cannot be defined. There are so many questions with answer, but there are so many questions without answer. So this thing cannot be defined. Everything has its limit. In this thing, you are having limit that your A should be greater than 0. A cannot be 1. A should not equal to 1. And your x is greater than belongs to R, that is real number. That means the domain of x is what? Real number. And y belongs to R plus. R plus means what? What? Yes, positive real number. Okay. So since it is violating the condition, this particular term log sine 45 by with base tan 45 is undefined. Okay. Let's have one question for the log. So we can recall the things that the concept that is explained right now is clear to you or not. If the condition, if log x square minus 2x plus 65 with base 5 minus x equal to 2, then x equal to what? What is the question? Log x square minus 2a plus 65 with base 5 minus x equal to 2, then x equal to what? Let's start to solve. Recall the condition. A should not be greater than, it should be greater than 0 and A should not equal to what? What? 1. Right? 1. So if 5 minus x is greater than 0, so can you say x? Can you say x less than 5? Can you say x less than 5? That means 5 minus something should be greater than 0. So x should be less than 5. And with this thing, this condition, we can get x what? X what? X cannot be equal to something. X cannot be equal to something what? If x equal to 4, 5 minus 4 equal to 1, but we can't have 1, so x is not equal to 4. Okay? So here we are having two results that is going to be used to solve this question. X should be less than 5, x should not not equal to 4. Okay. Now, according to this thing, according to our information that we have till now, it can be written. Okay. X square minus 2x plus 65 equal to 5 minus x to the power 2. Can you write it? Yes, of course you can write it. When you solve it, you can do it like this. Correct. If I'm correct or not. X square minus 22x plus 65. 5 square. 25x square. X square 2ab. 2 into 5 into x, that is 10x. And since it is minus, it will be minus. A minus b whole square equal to a square plus b square minus 2ab. Am I clear? Is this thing clear? Yes. That's good. X square cancel. This 10x can be here. So we will have 8x equal to 25 minus 65. So I think so it will be 40 with minus sign. And x equal to minus 5. How? Okay, let me explain it. 40 minus 40 divided by 8 is 5. Okay. So we are having x equal to minus 5. But we are having two conditions. So we need to check that x equal to minus 5. But x should be less than 5. Is minus 5 is less than 5? 5 is in the right hand side. Minus 5 in the left hand side. On the number line. So of course minus 5 is less than 5. And x should not equal to 4. Minus 4 is equal to 4. No. Minus 5 is not equal to 4. So this is following our condition. So we are having our result as x equal to minus 5. So x equal to minus 5 is our answer. Okay. So with this basic things we can solve this type of question like some big problem also. For some big problem we need some properties. Why? To make that big calculation easy. So we are going to see some properties of logarithmic. What properties of logarithmic? It said log m into n. M and n are two numbers. So log m into n, they are in product. With base a can be written as log m with base a plus log n with base n. Similarly, log m by n with base a equal to log m with base a minus log n by n with base a. Log a in log m to the power x with base a equal to x. And this power, if this power is here, like something to the power, so this power will come in the multiplication. So x into log m with base a. And the most interesting, a to the power a to the power log n with base a. So if a to the power log n with base a, so this base and this base are same, then we can easily write this particular thing, this particular quantity will equal to n. So these things are going to help you in many ways to solve the question. Okay, that's it for now. Thank you. Thanks for watching, and please let me know in the comment that what is your feedback, and give me some of your feedback so I can improve myself. Thank you.